Deep in the cold abyss of the cosmos, a star is dying, but not quietly. It's collapsing into itself, warping the very fabric of reality as it goes. Around it, time begins to stretch, bend, and slow. To a distant observer, this collapse may never finish. To the star, it's over in seconds. What if the laws of time, the one constant we thought we understood, are breaking down? What if this isn't just a star dying, but a window into the end of time itself? Or maybe its beginning. Join us as we dive into the heart of a cosmic paradox, where gravity suffocates time, and dying stars whisper the secrets of the universe. Subscribe if you still believe time has limits. In the dry highlands of Chile, beneath the ink-black sky, a giant of glass and steel gazes into the abyss. This is the European Southern Observatory, home to some of the most powerful eyes humanity has ever pointed at the cosmos. And in late October 2019, one of those eyes caught something strange. A star was dying, but not in the way we expected. No explosion, no violent burst of gamma rays ripping through the void. Instead, the light curve, the graph that tracks a star's brightness over time, began to behave unnaturally. It wasn't dimming quickly. It wasn't flaring either. It was stretching, slowing, lingered like a heartbeat that refused to stop. Dr. Layla Monroe, an astrophysicist monitoring the data stream, was the first to notice. At first, she thought it was a calibration error, a software glitch. But the data repeated, again and again, from multiple instruments. This wasn't a mistake. It was a mystery. And it didn't match any known category of stellar death. Normally, when a massive star exhausts its fuel, it collapses under its own gravity, creating either a neutron star or a black hole, a process that happens in a matter of seconds. But this object, located in a distant spiral arm of a galaxy 500 million light-years away, was behaving like neither. It was collapsing, and collapsing, but never quite finishing, almost like the star was caught between death and eternity. Monroe and her team dubbed it ECO 7. The name would soon become shorthand among astrophysicists for one of the most bizarre anomalies ever recorded. And as the days turned into weeks, they noticed something even more unsettling. The wavelengths of light coming from the star were redshifting, not just from cosmic expansion, but from something local, something gravitational, something that was stretching time. It was as if space-time itself was being pulled like molasses around this dying star. Imagine pouring syrup on a table and watching it ooze outward in slow motion. That's what this star was doing to time. But how telescopes around the world, from Hawaii to South Africa, locked onto the anomaly. Even gravitational wave observatories began to take notice, though the object wasn't emitting the violent signals associated with neutron star collisions. This was something different, something subtle, a slow-motion implosion playing out over months, while in its own frame of reference, it could already be over. Think about that. From our perspective, the collapse could take centuries. But for the star, for ECO 7, it may have ended long ago. A paradox of perception, a cosmic time trap. Dr. Monroe consulted collapse models, neutron degeneracy thresholds, equations about mass, pressure, quantum states. None of them explained what she was seeing, because ECO 7 wasn't exploding, and it wasn't cooling. It was suspended, caught in a war between gravity and time itself. And then came the twist that turned confusion into obsession. A faint pulse, buried in the spectrum of light, was a rhythm, so subtle it almost slipped past their instruments. like the ticking of a clock distorted by gravity. It repeated every few weeks, growing slower each time, as though the very heartbeat of this object was being drowned in spacetime. Some called it a dying star. Others whispered it might be something more, a pre-black hole, a theorized object that hovers just above the threshold of total collapse, something too dense to be a star, but not quite ready to fall into shadow. A gravitational phantom, a cosmic ghost. As more observatories joined the search, the data grew richer and more unsettling. This wasn't a one-time event. There were hints, faint echoes in sky surveys going back decades that other stars might have died like this before. We just hadn't looked closely enough. Could these frozen collapses be common in the universe? Had we missed them? Because they don't scream across space like supernovae do. What if most stellar deaths are quiet, suspended, stretching time into something unrecognizable? And if a star could do this, slow time to a crawl, what else could this be happening in the hearts of galaxies? In the early universe, in places where our physics begins to crumble, these questions aren't just academic, because understanding how time behaves under such pressure might unlock answers to our deepest cosmological puzzles. Why the universe is expanding the way it is. Why certain regions remain mysteriously cold. Even why the Big Bang left behind echoes we still don't understand. Dr. Munro's team would soon collaborate with theorists around the world. One of them, Dr. Thomas Velasquez, would pose a terrifying possibility. What if we found a star that didn't collapse, because time around it has nearly stopped? It was no longer just a question of light. It was a question of time itself, and it was only the beginning. What if there are stars scattered across the universe, paused, frozen, alive in death, still collapsing as we speak, but only in the silence of deep time? Time is a trickster. We grow up thinking it's simple, a ticking clock on the wall, a sunrise followed by sunset, a predictable beat marching us forward. But what if that beat isn't steady? What if time itself is elastic, shaped by invisible hands we can barely comprehend? In the early 20th century, Albert Einstein shattered our illusions. His theory of general relativity proposed something radical, that time doesn't flow at the same rate everywhere. It bends, it stretches, it can even slow to a crawl. And all it takes is gravity, strong gravitational fields, like those near massive objects, warp space-time. Not just space, but time itself. This isn't theory anymore. We've measured it. GPS satellites orbiting Earth must constantly adjust their internal clocks to stay in sync with ground time, because they're slightly farther from our planet's gravity well. And thus, time moves faster for them, just a fraction of a second, but enough to cause chaos if uncorrected. So imagine what happens near a collapsing star, one with dozens of times the mass of our Sun, squeezing into a volume no wider than a city. The gravity there is extreme, enough to trap light, enough to twist the rules. This is where we meet Dr. Thomas Velasquez, a physicist working with LIGO, the Laser Interferometer Gravitational Wave Observatory. He spent his life listening for tremors in space-time, the echoes of collisions and collapses we can't see with telescopes. When Dr. Velasquez reviewed the data on ECO 7, his face tightened. "This isn't just a collapse," he said. "It's a gravitational anchor, a clock that's running at a different pace than the rest of the universe." He pulls up a simulation, a simple graph, comparing time near the object versus time on Earth. The line is curved dramatically. If you hovered near equals 7, Just beyond its collapsing surface, 1 minute for you could equal months for us. Keep approaching, and time slows even more. As you cross certain thresholds, it nearly freezes. From our perspective, you become trapped in slow motion, but from yours, everything around you accelerates. Stars blur, galaxies race. The universe grows old in the blink of your eye. It's the twin paradox, not a thought experiment anymore, but reality. Einstein imagined identical twins, one traveling near light speed and returning younger than the other. With Eco 7, the same principle plays out, but without the need for motion, just proximity to a gravitational monster. Velasquez points to an equation on the screen, the Schwarzschild metric, a mathematical description of how time distorts near a spherical mass. We used to think black holes were the only places this got intense, he says. But Eco 7, it's something in between. It's a place where time folds inward, but doesn't vanish. This liminal state, neither a black hole nor a neutron. Star is rare. Most stars either explode dramatically or collapse decisively. But Eco 7 seems stuck. And it's this very in-between state that makes it a laboratory for studying time like never before. Imagine a spacecraft approaching it, equipped with a perfect atomic clock. As it nears the star, the clock slows. Aboard the craft, nothing feels strange. Time flows normally. But back home, months pass, years. The deeper it dives, the slower its clock ticks, until theoretically it approaches zero. We're not dealing with science fiction anymore. We're describing what our best physics predicts. But here's the twist. Even though time slows near massive objects, it never stops unless it crosses the event horizon of a black hole. Yet Eco 7 has no such horizon. It hasn't formed one. So what gives? What's holding it in this suspended state? Velasquez proposes a term, temporal liminality, a moment that never ends, a state where the collapse never completes, not because it's frozen in space, but because time has been pulled so deeply into the star's gravity that from our perspective, it's almost motionless. This is where philosophy begins to merge with physics. Because if time can vary so wildly depending on your position, what is time, really? Is it a universal river? Or is it local, subjective, shaped by the terrain of gravity? Einstein hinted at this over a century ago. The distinction between past, present, and future, he once wrote, is only a stubbornly persistent illusion. At Eco 7, that illusion is crumbling in real time. And here's where it gets even more haunting. If time can slow this much, near a collapsing star, could it also be manipulated? Could natural phenomena, or even civilizations far beyond us, use gravity to engineer time? What if somewhere out there, intelligent life has already figured this out? What if they built habitats around objects like Eco 7, places where time moves slowly, allowing them to outlive galaxies? Or perhaps, what if we are the ones inside the time bubble, watching a faster universe from within, too slow to notice the signs of intelligent design all around us? What would you do if you could slow time? Would you stretch a perfect moment forever, or escape an ending you're not ready to face? And as we begin to understand Eco 7, we're forced to ask something even stranger. If a star can slow time, could it also trap it? Because the deeper we look into this object, the more it seems like a prison not just for matter, but for chronology itself. And if that's true, what else might be waiting, locked inside time's shadow? Picture the universe as a giant rubber sheet, taut and stretched. On this sheet, you place a marble. it makes a dent. Place something heavier, a bowling ball, and the dent deepens. This is how gravity works in Einstein's universe. Massive objects bend the fabric of space and time. The more massive the object, the deeper the bend. But what if something so heavy appeared that it didn't just dent the fabric? It nearly tore a hole in it. This is exactly what scientists now believe we're witnessing with Echo-7. As more observatories zeroed in on the anomaly, teams at Caltech and the Max Planck Institute collaborated to create a 3D gravitational model of the region surrounding the star. What they found was nothing short of breathtaking. A gravity well so steep that light, traveling at 300,000 kilometers per second, was being slowed, bent, and in some regions, nearly caught Dr. Sophia Nilsgaard, a theoretical physicist at Max Planck, describes it like this: imagine standing at the edge of a canyon so deep you can't see the bottom. Now imagine that canyon isn't carved into rock, but into time itself. This isn't a black hole. Not yet. But Echo-7 is approaching that threshold. The gravitational slope surrounding it is extreme, but not infinite. The event horizon, the invisible boundary that defines a black hole, hasn't formed, and yet, time dilation in this zone behaves as if it has. The closer you get to the center of the well, the more intense the warping becomes. For an object drifting nearby, seconds stretch into hours, hours into years. If a spacecraft orbited too close, its crew might return home to find their civilization long gone. This gravity well isn't static. Data suggests it's deepening slowly, incrementally. Not enough to suggest immediate collapse, but enough to hint at something brewing beneath the surface. Echo-7 may be transitioning, evolving, and that's what terrifies scientists the most. Because if it does cross the threshold into becoming a black hole, we'll never see the final moment. Not really. From our perspective, the collapse will slow infinitely. The star will seem to freeze in time, radiating its final light forever, even as, from its own frame, it vanishes in seconds. This is known as gravitational time freeze. Not a literal stop, but a perceptual one. The star appears to halt because its light takes longer and longer to escape the deepening well. We see the past stretched across the present, like an echo looping endlessly. And yet, here's the paradox. Even though time is slowed from our viewpoint, from the star's perspective, everything continues. Gravity doesn't stop. Collapse doesn't stop. Only our ability to witness it does. It's a cruel trick of nature, to show us the beginning of a death we'll never see completed. But this opens up a new kind of question, one that has never been more than theory until now. Could there be physics within that freeze? What if the layers of space-time near Echo-7 are not just slowing time, but changing how time behaves altogether? Dr. Nilsgaard believes we may be entering a new frontier, one where time and gravity interact in ways we've never measured. Her team calls it pre-horizon physics, a realm where known laws begin to dissolve. But singularity hasn't yet taken over. It's like standing at the shoreline of a black hole, watching waves crash that don't exist yet. Within this twilight zone, strange phenomena could occur. Particles might behave differently. Radiation could leak in patterns we don't yet understand. In fact, some theories suggest this pre-horizon region may be responsible for cosmic effects we've attributed to dark energy, the mysterious force accelerating our universe. What if gravity wells like Echo-7 are leaking time, influencing the tempo of the cosmos around them? In simulations run at Fermilab, gravity wells were shown to influence not just local space-time, but vast regions, surrounding them, creating temporal distortions that ripple outward like slow-motion earthquakes. These aren't just wrinkles. They're rips in the rhythm of reality, and they're not necessarily rare. Archived sky surveys, when reanalyzed, show hints of other echo-like phenomena scattered across the deep sky. Dim points of light with strange light curves, stars that never finished dying, ghosts caught in gravity's snare. Could these be markers, breadcrumbs across the galactic map? If so, what are they pointing to? And here's where imagination becomes necessity. What if, in some rare cases, these wells are stable? What if the universe allows such objects to exist without collapsing into black holes? Could they be gateways, energy reservoirs, or something we've yet to conceive? Some scientists have even proposed using them. If we could understand how to safely orbit such a well, we might create time shelters, regions where time moves slowly, preserving life, data, even civilizations. But it's not without risk. One miscalculation, and you fall too deep, slipping past the point of no return, where time and space melt into singularity. And even more unsettling, what if someone else already tried? Eco 7 may be natural, but what if it isn't? What if it was created, not as a weapon, but as a monument, a timer, a vault? We've always thought gravity was a force, but near Eco 7, it's something more. A sculptor, a clockmaker, a storyteller etching secrets into spacetime itself. And, as we descend deeper into the well, we must ask, what story is it trying to tell us? There are stars, and then there are corpses. And some corpses refuse to rest. When a massive star exhausts its nuclear fuel, it dies a spectacular death. The outer layers explode outward in a supernova, while the core collapses inward with unimaginable force. If the original star isn't quite massive enough to form a black hole, what's left behind is a neutron star, an object so dense a teaspoon of its matter would weigh about 1 billion tons. But even among these collapsed remnants, there are extremes that defy our models. One of them is PSR J07 406,620, a pulsar located about 4,600 light-years away in the constellation Camelot-Dallas. In 2021, it stunned astronomers when new measurements revealed it to be over 2.14 times the mass of our Sun, compressed into a sphere just 25 kilometers wide. By all accounts, that shouldn't be possible, and yet it exists. These so-called massive neutron stars push the boundary of collapse, towing the line between staying intact and giving in to gravity's relentless pull. The space between them and full black hole transformation is razor-thin, a place theoretical physicist Dr. Annika Dar refers to as the edge of collapse. Dr. Dar has spent her career probing that line, where the known laws of matter begin to fail. Inside a neutron star, protons and electrons are crushed together into neutrons, but beyond a certain pressure, even neutrons break down. They become a soup of quarks, or something even stranger, hyperons, Kaon condensates, or exotic states we've never observed in a lab. What if, she asks, these extreme stars don't collapse all the way, because they find a new form of matter, a new kind of pressure, one we haven't accounted for? Eco 7 might be one such case. When Dr. Dar reviewed its mass estimates, based on lensing effects and radiation shifts, she realized something unsettling. The object was likely above the Tolman-Oppenheimer-Volkoff limit, the theoretical maximum mass for a stable neutron star. It should be a black hole, but it's not. Instead, it hangs in cosmic limbo. Neither star nor singularity. Something in between. The data suggests that Eco 7 isn't just resisting collapse. It's hovering on the edge, as if frozen in the act of falling. And that raises a staggering possibility. Maybe black holes don't form in an instant. Maybe some of them stall, suspended for eons, defying time and gravity simultaneously. If this is true, then the universe may be littered with paused collapses, objects that appear frozen. Not because they are stable, but because time around them is flowing like syrup over ice. And in that frozen moment, something strange may be happening inside. Some theorists suggest these objects are breeding grounds for exotic physics. Inside Eco 7, neutrons might be turning into pure quark matter, a state where particles dissolve into a fluid of fundamental components. Others believe the interior could be a graver star, a hypothetical object where collapse is halted by quantum effects, creating a bubble of repulsive pressure just before the event horizon would form. But without the ability to see inside, we're left reading shadows. Clues come from the way radiation escapes, or doesn't, from the shifting polarization of light near its edge, from faint neutrino signatures detected on Earth, so rare and ghostly. They require underground caverns and tanks of supercooled fluid to even register. In those faint traces, something emerges. Eco 7 is changing. Its emissions are evolving. It may be growing denser. If so, it's not frozen forever. It's moving, just impossibly slow. This introduces a terrifying idea that we are watching a live collapse unfold, but stretched across centuries or millennia from our vantage point. The collapse from within could be over already, but from here, we're watching a death that's still unfolding, still deepening, like a scream we'll never hear finish. And what's more chilling is this: if Eco 7 crosses the final line, we won't know. Not truly, because the moment it forms an event horizon, its final light is locked away, forever unreachable. To us, it will just fade, as if swallowed by silence. Dr. Dar sits in her lab in Bangalore, eyes locked on a simulation. She taps her stylus against the screen where the model of Eco 7 hovers in stasis. We used to think collapse was binary. Either it happens or it doesn't. But this is the in-between, the ghost state. And what if the in-between is more common than we thought? What if many of the strange X-ray sources in deep space, those that flicker without rhythm, are paused, stars caught in this same slow-falling limbo? What if black holes aren't just created, but become, over timescales we can't perceive? It reframes everything. Our understanding of stellar death, of time, of finality itself. And yet the biggest question remains: what happens inside a star that refuses to die? Because Eco 7 isn't just a physical object. It's a message, a paradox, a cosmic whisper saying, there is more to death than darkness, and we've only begun to listen. It was once a thought experiment, a playful test of Einstein's equations, the famous twin paradox. One twin boards a spaceship and accelerates close to the speed of light, while the other remains on Earth. When the traveling twin returns, less time has passed for them. They've aged more slowly. A science fiction trope, yes, but also a real, measurable prediction of relativity. Now, with Eco 7, that paradox isn't just theoretical, it's playing out in real time, across light-years. Dr. Thomas Velasquez's team at Caltech decided to run a new kind of simulation, one they'd never attempted with such gravitational extremes. What would happen, they wondered, if an astronaut orbited Eco 7 at a safe but close distance for a year, then returned to Earth? The results chilled them. From Earth's perspective, depending on the exact orbital radius, decades could pass. In some models, nearly a century, meaning if a crew member launched a mission to Eco 7 today and stayed in orbit for 12 Earth months, they'd return to find their children old, their friends buried, their home transformed beyond recognition. In essence, they'd traveled into the future without ever moving fast, just by sitting near a dying star. This isn't warp speed. This isn't a wormhole. This is gravity alone. Stretching time, Dr. Velasquez points to the relativity equations at the heart of the model, equations that have already been verified by satellites and atomic clocks. People think time travel is science fiction, he says, but time dilation is real. We're just not used to thinking on this scale. What's extraordinary is how accessible the concept becomes near objects like Eco 7, because it isn't moving quickly, it's not accelerating, it's simply massive. And that mass curves space-time so dramatically that time itself begins to misbehave. Now imagine a civilization with the technology to harness this. What if they wanted to skip ahead, to leap across centuries without aging? They wouldn't need a spaceship, just a station orbiting a gravity well, a time vault. Some have speculated that if intelligent life exists elsewhere, especially if it's older and more advanced, it may have already discovered this. Maybe they built observatories near collapsing stars, not for research, but for preservation, to endure the march of entropy, to wait out danger, to hide, because here's the other side of the twin paradox. It isolates you. For every year you spend near the gravity well, your world moves on without you. News ages, languages evolve, stars drift. The longer you stay, the more alien your home becomes. It's not just time travel, it's time exile. In a recent experiment, Dr. Velasquez's team created a full VR simulation of such a journey. Viewers reported intense emotional disorientation, the horror of watching Earth age in fast forward, of returning to a world that no longer remembers you. Some cried, others refused to finish. The simulation underscored a haunting truth. Time dilation isn't just science. It's psychological, emotional, existential. Now, let's go even further. Suppose you're on a planet orbiting a star like Eco 7. You wouldn't notice anything strange at first. Days would feel normal, seasons would come and go, but viewed from afar, your world would seem to move in slow motion, as if trapped in syrup. Generations outside might live and die while you sleep through a single night. Could life evolve in such a place? Biologists speculate that slower time would reduce mutation rates, slow metabolism, prolong lifespans. Evolution might be glacial, but survival rates could be high. A civilization here might be long-lived, deeply reflective, but to us, nearly invisible. We might already be watching them, mistaking their slow transmissions for background noise. Their messages could span decades, each word stretched by gravity. What if some of the static we hear from space is just someone else speaking through time? And here's the most sobering part. We, too, are in a gravitational field. Earth's, the Sun's, the Milky Way's. Time moves slightly slower here than it does in interstellar space. Not enough to notice microseconds per year, but it means that every second you live is already a distorted one. You are the twin who stayed behind, so the paradox isn't out there, it's here. We live in it. What would it mean to take that seriously, to acknowledge that time isn't a river flowing uniformly, but a shape warped and twisted by invisible masses, that your life is a story told at a tempo the universe constantly rewrites. And if you could change the tempo, would you slow time to hold on to a fleeting moment? Or would you leap ahead, sacrificing now for the promise of what comes next? Because in the shadow of stars, like Eco 7, that choice is more than fantasy. It's physics. The twin paradox has become our reality. And it's just the beginning, because Eco 7 isn't just stretching time. It may be erasing the boundary between past and future entirely. The event horizon, nature's ultimate curtain. We're taught that, around a black hole, it's the line you cannot cross and ever return. Pass it, and you're erased from the visible universe, your future cut off, your story forever hidden, behind a wall of infinite gravity. But what if Eco 7, the star that refuses to die, is exposing something altogether stranger? What if it's not the event horizon warping time, but something else entirely? Dr. Javier Chen is no stranger to paradox. A theoretical physicist at the Institute for Advanced Study, Chen has built his reputation on dismantling cosmic dogma. He pores over Eco 7's data, frowning at graphs that ripple and slow, refusing to obey any known formula. He's quick to point out a crucial fact. Eco 7 doesn't have an event horizon. It's not a black hole. But the time dilation around it is almost as severe. So what's really causing this effect? To answer, Chen draws a mental map. In a typical collapse, as a star's core compresses, the gravity at its surface intensifies, warping time more and more. The instant the collapsing mass reaches the critical radius, the Schwarzschild radius, the event horizon forms. From outside, the infalling matter appears to slow, asymptotically, never quite crossing. But at Eco 7, no horizon appears. The star hovers in a twilight, teetering on the edge of oblivion. Never falling in, Chen proposes a radical alternative, the gravity well plateau. Picture a hill that climbs ever upward, then flattens near the peak. The slope is still steep, time still slows, but there's no sharp cliff, no true edge. This plateau, he argues, could form when certain unknown quantum effects push back against collapse. The result, an ultra-dense object dense enough to mimic the time-warping powers of a black hole, but lacking its terminal singularity. This not-quite black hole isn't merely a curiosity. It's a new state of matter, a cosmic halfway house between neutron star and event horizon. Inside, neutrons are crushed, but not destroyed. Quantum forces, and perhaps even exotic forms of pressure, dark energy, vacuum polarization, or as yet undiscovered particles counteract gravity just enough to stall the final collapse. It is neither dead nor alive. It is paused. Simulations at the Kavli Institute for Theoretical Physics show that such gravity well plateaus, if real, would produce all the hallmarks of time dilation, the stretched light curves, the slope, pulse, the gravitational redshift, without the information loss paradox that has haunted black hole physics for decades. No information vanishes behind an unreachable boundary. Instead, it's frozen, decelerated almost to a halt, but not lost, if true. This would append more than a century of assumptions. It would mean that nature, in some rare cases, resists the urge to cut off its stars from the universe. It would mean that time can be throttled without vanishing, that collapse can stall indefinitely, that a kind of cosmic memory survives even as the clock ticks slower and slower. Chen's hypothesis stirs fierce debate. Some colleagues argue it's wishful thinking, a mirage conjured by incomplete data. Others whisper that it could finally explain why we never see the final plunge of a black hole, why some collapsing stars seem to fade instead of vanishing, why certain X-ray emissions pulse on 4 decades when models say they should be gone. And then there's the question of Hawking radiation, the ghostly energy predicted to seep from the edges of true black holes. If Eco 7 isn't quite a black hole, does it still radiate? Or does the absence of an event horizon mean information is never truly lost, that what goes in could theoretically come out again? For Chen, the question is personal as well as scientific. His mentor lost to cancer before the first gravitational waves were detected, used to dream of finding an object that would shatter our notions of collapse. We all want to know what's on the other side of the horizon, he says, voice low. Eco 7 might be showing us there is no other side, just an endless twilight, a story unfinished. This new paradigm, gravity well plateau, could change how we think about cosmic evolution. Are there galaxies seeded with these paused stars? Could their strange gravity subtly shape the orbits of planets, the paths of comets, the formation of life? If time is warped but not sealed, what becomes possible for information, for memory, for causality itself? What would you do, standing at the edge of such a plateau, staring into the slowest seconds in the universe? Would you risk a step forward, or back away from the brink? Because at Eco 7, there is no curtain, only a horizonless stage, and a drama still unfolding. In the farthest reaches of the electromagnetic spectrum, the universe hums with signals. Some are cosmic background noise, the faint whisper of the Big Bang. Some are the regular heartbeats of pulsars, clocking out the rhythms of dead stars. But every now and then, telescopes catch something stranger, a radio frequency that defies easy explanation, stretching and slowing, as if it's been caught in a web. With Eco 7, those signals became a riddle that would haunt the minds of astronomers. It started with a whisper. The European Southern Observatory, in partnership with the South African Meerkat Array, recorded a burst of radio waves from the region surrounding Eco 7 at first. It looked like static, just another transient, a hiccup in the galactic background. But as the data streamed in, the radio team led by Dr. Leela Munro and Dr. Rajiv Patel noticed something odd. The signal was smeared. The peaks flattened and spread apart in time, not by distance alone, but by some local effect. Even more unnerving, the pattern didn't match the classic signature of a pulsar or a fast radio burst. It was as if the signal itself had been stretched on a cosmic rack. When Munro overlaid the light curve from Eco 7's visible spectrum onto the radio profile, the correspondence was undeniable. Each pulse of light was paired with a pulse in radio, but the radio pulses arrived delayed, warped, sometimes minutes or hours after their light companions. We were seeing information move at different speeds, Munro explained in a press conference, as if the radio wave had to swim through molasses while the light darted past. Patel hypothesized that what they were observing was not just gravitational lensing, but gravitational time dilation. The radio signals from Eco 7, less energetic and more vulnerable to the stretched fabric of space-time, were being delayed, more dramatically than their higher energy cousins. It was the first time anyone had seen time distortion play out so explicitly across the electromagnetic spectrum. But then things got weirder. Machine learning algorithms, sifting through months of data, began to pick out patterns, subtle, recursive structures hidden in the stretched signals. a repeated motif, appearing every 27 days, then slowing to 29, then 33, as if the ticking of a cosmic metronome was losing its grip. These were not the fingerprints of chaos. They hinted at order, or at least intention. The press leaped on. The idea of alien messages, headlines screaming about signals from the edge of time. Monroe and Patel were more cautious, but they didn't dismiss the excitement out of hand. If there is information locked inside these stretches, Patel said, it's likely a natural process, encoded by the way matter and energy interact at the threshold of collapse. But that doesn't make it any less profound. The universe could be speaking to us through the language of physics. This is where science meets poetry. What if, as a star collapses and time slows, every signal it emits, every photon, every radio wave is preserved, not lost, but drawn out, like a voice echoing in a canyon that never ends? If you could listen long enough, with instruments sensitive enough, maybe you could reconstruct the entire death song of a star, stretched to infinity. And yet, there's a deeper, more haunting implication. Because if time dilation can preserve signals, it can also trap them. There could be countless messages, stories, warnings, raw information frozen in the slow death throes of stars all across the cosmos. Impossible to decode unless you understand how time itself has been twisted around them. In the cold underground corridors of the SETI Institute, Dr. Natalie Suarez, a leading researcher on extraterrestrial signals, was riveted by the ECO7 data. We've always searched for the extraordinary in rapid bursts and clear patterns, she reflected, staring at a wall of shifting graphs. But what if intelligence, or at least the most interesting cosmic information, hides in the slowest things? What if the universe stores its memories in slow motion? She commissioned a global decoding challenge. Can you, or anyone, extract meaning from the recursive patterns embedded in the stretched pulses? Within days, thousands of amateur radio astronomers and coders around the world joined in, scouring the data for meaning. Comments exploded online with theories. Some claimed the pulse sequence matched prime numbers. Others saw Fibonacci spirals. A few even mapped the data onto musical scales. It may be nothing more than cosmic music, the universe improvising on gravity's theme. Or perhaps, as some daring minds suggest, these slow pulses are a kind of natural archive, a backup drive for reality itself, preserving the last breath of a star for those patient enough to listen. What would you send if you knew your message would only arrive when the universe itself had slowed to a crawl? Would you risk everything for the hope that one day some intelligence would find your words, not lost, but frozen, waiting to be heard in a future neither you nor your world could ever imagine? The universe is a haunted library, its shelves, lined with dying stars whispering across our yawns. An ECO7 may be its rarest, most mysterious book yet. If you want to understand the meaning of time, watch a clock. Each tick, a promise. 1 second gone, one more arrives. But place a clock near the edge of ECO7, and something eerie happens. The ticks slow. The promise begins to falter. Until, in the deepest shadow of this collapsing star, the clock all but stops, and time itself seems to freeze. In labs across the world, from Paris to Pasadena, physicists simulated what would happen if you took the world's most precise atomic clock, the kind that measures time with vibrations of cesium atoms, and sent it toward ECO7. The results were both mathematically beautiful and existentially disturbing. At a safe distance, the clock ticks normally. As it draws closer to ECO7, Each tick grows further apart, seconds stretching into minutes, then hours. At a critical boundary, the gravity well plateau, as Dr. Chen named it, the ticks come so slowly, so reluctantly, that for distant observers, the clock appears to stop. But for the observer traveling with the clock, nothing feels strange. Time flows, heartbeats continue, thought and experience persist. It's the outside world that seems to speed up, racing past in a blur. This is the greatest illusion. Time feels absolute inside your bubble, but in the universe's larger frame, you are drifting into near-timelessness. Dr. Chen's team pushed the simulation further. What if the clock crossed the plateau entirely? What if it plunged toward the heart of Eco 7, where the densities grow extreme and the rules of matter begin to bend? In the model, time dilation becomes so severe that the next tick would take millions of years to reach distant eyes. The clock might as well be frozen for eternity. It's a haunting thought, a region of space where time, the very stage for all events, grinds to a halt. Physics textbooks describe time as a river flowing endlessly onward. But near Eco 7, that river meets a glacier and slows to a crawl. If the collapse continued, a true black hole would eventually form, the clock's final tick sealed forever from the outside. But Eco 7 is different. The clock is stalled, but the final curtain hasn't fallen. It's a cosmic waiting room where causality grows faint and the arrow of time wavers. This isn't science fiction. We already see hints of this phenomenon in our own solar system on a much smaller scale. GPS satellites, further from Earth's center, experience time a little faster. The clocks in the deepest mines on Earth, closer to the planet's core, tick a tiny bit slower. Time is not universal. It's local, shaped by gravity, stretched by the presence of mass. Yet Eco 7's effect is so dramatic, it invites new questions. What happens to information trapped inside a region where clocks won't tick? Does it ever escape? Is it preserved forever, or does it dissolve into some quantum fog? Could something or someone survive there, living out endless years, while the universe outside ages and dies? Dr. Leela Monroe, peering at her simulations late into the night, was struck by a deeply personal thought. If time can stop here, does that mean nothing ever really ends? That there's always a part of us, a memory, a moment, frozen somewhere, waiting to be seen again. Such regions could be the universe's natural vaults. Not black holes that erase all, but halfway houses where information is preserved, stretched out over eons. Perhaps some of the oldest data in the cosmos, the most ancient echoes, are trapped in these places, waiting, like messages in a bottle, for some future civilization to decipher them. Viewers around the world, following Monroe's team's live updates, began to send in their own questions. If you could pause time for a moment, would you? What would you do in your one perfect second? The responses ranged from romantic to philosophical to tragic, a reminder that time's relentless march touches us all, and the wish to freeze a moment is as old as memory itself. But the physics, too, becomes a mirror. If a clock can slow to nothing near a dying star, what does that mean for the story of the universe? Could the future already be written in slow motion, unfolding so gradually that even galaxies would miss it? Or could it mean that endings are illusions, that somewhere, even now, the past is still happening, just caught in a clock that refuses to tick? Eco 7's clock is more than a metaphor. It's a challenge to everything we know about beginnings, endings, and the spaces in between. And as we peer into its shadow, we're forced to ask, what might we find if we listened long enough for a tick that never comes? Imagine a world drawn perilously close to a star like Eco 7. The sky is a strange haunted blue, darker at the zenith, tinged with the blood red of a sun stretched thin by gravity. On this world, time itself is a sluggish current. Every heartbeat, every breath, every tick of every clock is stretched out, drawn long and slow by the colossal mass dominating the sky. For the inhabitants of such a place, time would feel normal. They would work, sleep, fall in love, raise families, live and die, believing their days passed just like ours. But to an outside observer, watching from the safety of the galaxy's brighter regions, their entire civilization would unfold in slow motion, as if submerged in thick oil. Decades for them would be centuries, even millennia for us. What would it mean to be conscious inside such a freeze frame? To live unknowing, inside a bubble where the universe races by and your own world is a slow dance? Biologists and philosophers alike are haunted by this scenario. Some speculate that evolution on such a world would crawl, natural selection unfolding at a glacial pace. Others suggest it could produce beings of profound patience, creatures for whom urgency is an alien concept, whose entire existence is built on reflection, endurance, and subtle change. Would life even recognize itself as slow? Or would its own rhythm be all it knew? A team of astrobiologists at the University of Vienna constructed computer models of hypothetical ecosystems orbiting gravity wells. The results were beautiful and unsettling. Forests growing at a rate invisible to the eye, rivers carving valleys, over what felt like millions of years to outsiders, but to the creatures on the surface, it was just another cycle, another season. Lightning flashes lingered, thunder rolled for hours, and shadows moved across the land so slowly that no living eye could detect their passage. Yet in this languid world, memory would be a different thing. Perhaps such beings would cherish stories, not over years, but across epochs. Maybe their historians would count the lives of entire forests or rivers as the core of their culture, a civilization not of quick innovation, but of deep, enduring tradition. And here's a mind-bending twist. What if time isn't just slow, but variable? Imagine traveling from the edge of this world, where gravity is weaker and time moves a little faster, toward its center, where the pull of Eco 7 is strongest and clocks drag ever more sluggishly. To journey across one's own planet would be to cross epochs, to move between generations in a single day. Communication, travel, even relationships would be shaped by gradients of time, making the very idea of now a negotiation, not a given. Could a civilization build technology to navigate these differences? Could they develop philosophies to accept the relativity of every moment? Would their art strive to capture a single instant, or to stretch the meaning of forever? But the greatest mystery lies in the question, could we ever recognize such a civilization? From our perspective, their signals would be faint, drawn out, perhaps indistinguishable from noise. Their attempts to communicate could take centuries to arrive, centuries more to be understood. Maybe, somewhere in the galaxy, we're already listening to their music. We just haven't learned to slow down enough to hear it. And then, an even more haunting possibility. What if we are not the fast ones, but the slow? What if the rest of the universe races on a tempo we can't perceive, and our entire history is a pause in the story of something greater? Is our civilization a momentary flicker in someone else's slow, patient universe? Astrophysicist Dr. Leela Monroe muses late one night, maybe the real loneliness isn't that we haven't found life, but that we're out of sync, that our clocks and theirs never match. Maybe we're all trapped in our own freeze frames, waving across centuries that never overlap. So we look up, straining for a glimpse of movement in the frozen light of Eco 7. We search for messages in static, for patterns in the long echo of a star that won't let go. And all the while, the universe keeps turning, sometimes slow, sometimes fast, always indifferent to the rhythm of our hearts. If you lived in such a world, would you want to know? Would you try to break free, or would you find comfort in the endless patience of a life where nothing is ever rushed? Inside the freeze frame, every moment is a universe, and every universe, perhaps, is waiting for its time to begin. Somewhere at the crossroads of theory and legend, Stephen Hawking proposed a cosmic paradox, that black holes aren't completely black. Instead, they glow ever so faintly, radiating energy as they slowly evaporate into the night. This whisper of energy, called Hawking radiation, is almost undetectable, the ghost of a star's final breath, dissolving into quantum foam. But what if Hawking's ghost still lingers, even in places where black holes have never truly formed? What if Eco 7, this star that refuses to die, radiates its own strange echo across time? Dr. Thomas Velasquez had been fascinated by Hawking's theories for decades. When he first saw the time-stretched data from Eco 7, he wondered if it might offer the perfect laboratory to test the boundary between black hole and something else. If Hawking radiation is real, he explained to a packed auditorium, then even a near black hole, a star teetering on collapse, might leak energy. Not a roar, but a whisper. He and his team devised a series of sensitive observations, tuning telescopes to the lowest energies, the faintest flickers, in search of a signature. What they found was subtle, nearly lost in the background hum. Tiny, persistent emissions of X-rays and gamma rays, pulsing in slow, periodic waves. The frequencies didn't match any known process of neutron star decay or pulsar emission. They seemed to emerge from the boundary where time dilation was at its most extreme, a place, according to Hawking's equations, where quantum effects could matter most. If these emissions were indeed a kind of proto-Hawking radiation, Eco 7 would become the first object ever observed to straddle the line. Not quite a black hole, not simply a neutron star, but a failed singularity leaking energy through the cracks in spacetime. The implications sent shockwaves through the theoretical community. At MIT, a young physicist named Dr. Riley Kamar ran models that suggested this slow radiation could last not billions, but trillions of years, far outliving the visible life of any star. The process is agonizingly slow. Eco 7 might sit in its liminal state, glowing faintly, long after galaxies have faded, holding on to its secrets with the patience of eternity. But there was something stranger still. As Dr. Velasquez's team continued their study, they detected odd fluctuations in the timing of these emissions, little jumps and pauses, like a cosmic Morse code. What could cause such a pattern? Was it a relic of the star's interior, matter rearranging itself in quantum fits and starts? Or was it a signature of the spacetime around Eco 7, rippling with gravitational echoes from its own incomplete collapse? Theorists began to wonder, could these echoes hold information? Might they encode some hidden aspect of the star's past, or even, in some quantum sense, its future? If Hawking radiation is a form of loss, a star's final sigh? Could these temporal echoes be memory, a kind of cosmic afterimage, preserving not just energy but information, stretched out across the slowest seconds in the universe? To explore this, Dr. Kumar collaborated with quantum information expert Dr. Mina Solberg in Copenhagen. They proposed that the strange timing of emissions might arise from entanglement, the spooky quantum link between particles, even across vast distances. If true, then Eco-7's dying breath would not just radiate energy, but quantum information, weaving the memory of its own collapse into the fabric of the cosmos. The idea is radical. If correct, it suggests that no information is ever truly lost, even in the slow death of a failed star. Instead, the details of Eco-7's past are encoded in the flicker of its ghostly radiation, available to any future civilization clever enough and patient enough to decode them. Across the internet, amateur scientists joined the hunt. Data archives filled with time-stamped X-rays, spectral lines, energy maps, all ripe for pattern recognition. Comments flourished. What if we're listening to the autobiography of a star? Are these echoes a warning or a message of hope? Some even tried to turn the data into music, mapping the slow pulses and tiny jitters onto piano keys. The result was haunting. A lullaby stretched thin across centuries, beautiful and unsettling. And here's the twist. If Eco-7 is not alone, if other stars hover on the edge of collapse, leaking temporal echoes of their own, then the universe is alive with memory. The cosmos becomes not a silent graveyard, but a hall of whispers. Every failed collapse, every near-miss black hole, becomes a storyteller, unraveling the history of matter and energy in the slowest language imaginable. As the data from Eco-7 continues to stream in, scientists and dreamers alike gather at the edge of knowledge, waiting for the next pulse, the next ghostly breath. What will it say? Will it reveal the fate of the star, the destiny of all things, or merely the deep, patient music of time itself? Perhaps, as we listen to Hawking's ghosts, we'll begin to understand the end of a star is never truly the end. It is a conversation with eternity. Science sometimes leads us to doors we never intended to open. Eco-7 is one such door or portal, not just to a new understanding of collapse and time, but to questions about the very architecture of reality. As the world's telescopes and supercomputers peered deeper into its data, a wild new hypothesis took hold. What if time, as it slows and contorts near Eco-7, doesn't simply grind to a halt? What if, instead, it reflects bounces, back birthing something entirely new on the other side? Welcome to the Mirror Universe hypothesis. This bold idea began with Dr. Eva Toussaint, a cosmologist at the Institut d'Astrophysique de Paris, who noticed a peculiar symmetry in the mathematical descriptions of Eco-7's collapse. The equations, she explained, are almost as time slows toward the edge, the math suggests a potential for reversals if the end is also a beginning. That's more than poetic. It's a radical reimagining of what it means for a star to die. Let's visualize. As the stars collapse, stretches time nearly to infinity, the fabric of space-time itself becomes taut, like a drumskin at its breaking point. Instead of snapping, what if it rebounds, sending a shockwave not into our universe, but into a mirrored realm on the other side of that boundary? In this speculative mirror universe, time might run backward from our perspective. Entropy could decrease, not increase. Perhaps their stars are being born as ours die, It sounds like science fiction, but the underlying math rooted in CPT symmetry, one of the deepest principles of quantum field theory, does not rule it out. For every process, there could exist a mirror process where charge, parity, and time are inverted. Dr. Toussaint and her team ran high-powered simulations using ECO7's parameters. The results: at certain thresholds, the model didn't simply fail or stop it inverted, hinting at a kind of cosmic bounce. This idea caught fire among theorists. Online forums erupted with debates. Could the Big Bang itself have been a rebound from a collapse in a mirror universe? Is every black hole, every stalled star, the seed of a new cosmos, ours or another's? Some called it elegant, others heresy. But the universe, history reminds us, is rarely constrained by human comfort. And there's a curious observational twist. In analyzing the oldest light in the cosmos, the cosmic microwave backgrounds, scientists have found anomalies, cold spots, strange alignments, statistical oddities. A handful of researchers now wonder, are these scars from mirrored bounces, cosmic imprints from where universes nearly touch? Could ECO7, and objects like it, be the pivots where realities brush past each other, their stories mingling at the boundary of time? The human mind reels at such implications. If this is true, then nothing ever truly ends. Every collapse is a prelude, every death a reflection. Maybe even our own universe is a mirror image of another, just as haunted, just as wondrous, just as full of longing for what lies beyond the veil. Dr. Toussaint finds herself both skeptical and enchanted. We don't know if the mirror is real, she admits, but the possibility is too beautiful to ignore. If the universe has a shadow, a twin perhaps somewhere, every hope, every loss is reversed, redeemed, and born anew. At the edge of theory, philosophy takes over. What would it mean for us, personally, if our own endings birthed new beginnings elsewhere? If every decision, every failure was balanced by a mirror triumph? The idea isn't just cosmic, it's profoundly human, a comfort, perhaps. In a universe so often ruled by finality, as scientists continue to probe ECO7, scanning its echoes for clues of a mirrored reality, they invite the public to imagine with them. Social media lights up with speculative art, poetry, and digital simulations. If you could send a message to your mirror self, one post asks, what would you say? Would you warn them or wish them luck? The mirror universe hypothesis may remain just that, a hypothesis. But for now, it's changed the way we look at the slow, strange death of stars. No longer just the end, but a threshold, a question mark beckoning us forward, and somewhere in the depths of ECO7, perhaps the reflection has already begun. As ECO7's riddle deepens, speculation pulls us into the wildest frontiers of physics where space-time twists into paradox, and the laws we take for granted shimmer on the edge of reason. Here, on the shores of the unknown, scientists ask, could the gravitational weirdness around a collapsing star do more than just slow time? Could it punch holes in reality itself, or even give rise to new forms of matter phenomena so exotic they border on science fiction? Let's explore 3 of the strangest possibilities: wormholes, time crystals, and the wild edge where the universe rewrites itself. First, wormholes. Picture space as a vast sheet. Gravity, like ECO7's, can bend that sheet, folding distant points closer together. A wormhole is the ultimate folder tunnel through space-time, linking to distant places, or even to different times. Theoretical physicist Dr. Javier Chen has devoted his life to the Einstein-Rosen bridge, the classic wormhole solution to Einstein's equations. Until now, such shortcuts have seemed pure mathematics, always collapsing before they could be crossed, unless held open by negative energy. Something never observed, but around Eco 7, Chen notices something tantalizing: the incredible time dilation and warped spacetime. Geometry create the closest conditions we've ever seen to the mouth of a wormhole. Quantum fluctuations grow wild at the gravity well's edge, and spacetime itself behaves like a fabric stretched to tearing. In theory, if exotic matter or quantum effects intervene, a stable passage might form for the briefest instant. It's still speculation, Chen admits, but Echo 7 might be our best chance to glimpse or even trigger a natural wormhole. Could such gateways be common in dying stars? Could some be permanent cosmic shortcuts connecting the farthest corners of the universe? Now, two-time crystals, a name that sounds like fantasy, but is rooted in hard science. Proposed by Nobel laureate Frank Wilczek in 2012, time crystals are structures that repeat not just in space, like ordinary crystals, but in time. They oscillate forever without using energy, something thought impossible until laboratory experiments proved otherwise. In the heart of Eco 7, where time is stretched to its breaking point, the conditions for forming natural time crystals may exist. Quantum physicist Dr. Mina Solberg and her team at Copenhagen University have modeled how the freezing, jittering spacetime near the star could coax particles into a perpetual temporal dance. Imagine a region where particles flip and twirl endlessly, never aging, never changing, the ultimate expression of frozen time. These time crystals could be stable for eons, acting as cosmic clocks, or even vaults of information. If we could harvest or interact with such a structure, we might unlock new technologies: quantum computers that never degrade, memories that last until the universe ends, or even new ways to communicate across time. But as speculation escalates, so does skepticism. Many physicists warn that such ideas dance on the knife's edge of reason. Wormholes, time crystals, and other phenomena at the brink of collapse are fraught with instability. Tiny changes in conditions could shatter them, turning a potential miracle into disaster. Still, Eco 7's unique environment offers a rare laboratory to probe these limits. Experiments are already underway, searching for repeating signals, measuring strange correlations in radiation, hoping for the telltale signature of a wormhole's mouth or a time crystal's eternal oscillation. The edge of reason is not just a phrase. It's a location mapped out by risk and imagination. For every scientist drawn to Eco 7, there's a moment when data turns to dream and theory to myth. And yet, science thrives herein, the places where certainty dissolves. This isn't only about equations. It's about humanity's deep yearning to escape the ordinary. Viewers are invited to imagine, what would you do given a passage through space and time? Would you venture into a wormhole, not knowing where or when you'd emerge? Would you leave a message in a time crystal, hoping it would endure long after your world is gone? Would you dare to experiment at the universe's most unstable edge? Children in classrooms build their own models of wormholes with paper and string. Online forums fill with animations of glimmering time crystals, imagined as glowing jewels in the void. Artists sketch what it might feel like to cross the threshold into a region where the universe forgets its own rules. As the search continues, data from Eco 7 will either confirm or crush these dreams. But until then, the mystery remains alive. A whisper at the threshold of what is possible, daring us to wonder if time, space, and matter can ever be truly tamed. Because at the edge of reason, anything is possible, nothing is. Eco 7 waits, holding its secrets. Beneath every cosmic mystery lies the hunger for a single answer, a unifying law, a God equation that ties all of reality together. Einstein dreamed of it. Modern physicists still chase it. In the equations that govern gravity, quantum mechanics, and the fundamental forces, they search for harmony. But sometimes, a star like Eco 7 appears, and the math starts to break. Dr. Javier Chen sits in his office surrounded by chalk-dusted blackboards, wrestling with a question older than his career. Why do the laws that work so perfectly elsewhere fail here, in the liminal twilight of a collapsing star? The math predicts that if you push enough mass into a small enough space, a black hole forms. Quantum field theory, on the other hand, says information and energy must be preserved, never lost. But Eco 7 exists in defiance of both, hovering between star and black hole, as if refusing to obey either command. To understand why, Chen and his international team turned to string theory, the most ambitious attempt to write a cosmic theory of everything. In string theory, every particle, every force, is the result of vibrating strings of energy moving through a hidden, multidimensional landscape. For years, string theory has produced beautiful math, but little testable evidence. Then, Eco 7's data arrives. As Chen's team plugs in the observed mass, radius, and the time dilation factors from Eco 7's region, they find something shocking. The equations, which should remain symmetric and stable, begin to destabilize. Certain solutions blow up, spitting out infinities, breaking the clean tapestry of physical law. Eco 7 is not just a problem, Chen mutters into his recorder, it's a challenge. It tells us the universe is deeper or stranger than the equations we've written so far. What might be causing this mathematical rebellion? One possibility is that Eco 7 isn't governed by the rules of our universe at all, but by new laws that emerge only under the extreme conditions near the gravity well plateau. String theorists call these phase transitions, places where reality itself changes texture, like water freezing into ice or boiling into steam. At Eco 7, perhaps time, space, and even causality freeze into new forms. To explore this, Dr. Chen's team runs a set of computer simulations, layering quantum gravity effects onto the conventional collapse models. Sometimes, the math stabilizes, suggesting a new, undiscovered symmetry is trying to assert itself, a deeper order beneath the chaos. But, at other times, even the computers fail, generating nan values, nan numbers that mean the program has reached a domain beyond comprehension. Other theorists propose that Eco 7 may be revealing cracks in the foundation of physics itself. Maybe the unification of gravity and quantum mechanics requires an ingredient we've never found, a fifth force, a hidden particle, or an entirely new dimension. Perhaps what we see as paradox is really just a sign that we're missing part of the story. But the challenge goes further. For decades, physicists believed in cosmic censorship, the idea that nature hides its singularities, its breakdowns behind event horizons. Eco 7 suggests this censorship can fail. Here, in the open, the laws of physics go rogue, and we are allowed to peer into the very engine room of the cosmos. There's an emotional cost to this frontier. Dr. Chen confides to a colleague, it's exhilarating and terrifying. We want a tidy universe, but the truth may be wild. Maybe the God equation isn't one equation at all, but an ever-shifting web, adapting to the needs of each star, each event, each collapsing moment. The world watches as Chun's findings are published. Forums light up with questions. What if our laws only work at human scale? What if, at the heart of reality, the universe is lawless, or ruled by laws so alien we can't yet imagine them? If so, how much of what we know is simply comfort, not truth? But with every new paradox, there's hope. For in breaking our math, the universe is inviting us to write better equations, to keep searching, keep questioning, keep wondering. So, what will it take to crack the code of stars like more powerful telescopes, bolder mathematics, or perhaps, as Dr. Chen hopes, a new way of thinking entirely? And if we ever find the true God equation, will it be the end of mystery, or only the beginning? Because in the lightless edge, where Eco 7 waits, the math may break, but curiosity only grows stronger. The universe keeps a record of its own childhood, written in light older than any star. That record is the cosmic microwave background, a faint, almost ghostly glow that suffuses all of space, carrying echoes of the Big Bang itself. For generations, scientists have studied this ancient light like archaeologists reading the first cave paintings, seeking clues to the universe's earliest moments. But what if, hidden in the fog of that primordial glow, are distortions and signatures from objects like Eco 7, subtle warps that rewrite the very story of creation? For decades, the cosmic microwave background, CMB, has been our most reliable witness. It's the leftover heat from when the universe cooled enough for atoms to form, allowing light to travel freely for the first time. The Planck satellite, WOMAP, and countless ground-based telescopes have mapped this radiation in exquisite detail, revealing hot and cold spots, tiny variations that seeded the galaxies and clusters we see today. Yet, anomalies remain, cold spots deeper than theory predicts, odd alignments, unexplained ripples. Astrophysicist Dr. Annika Dar, poring over fresh data from the South Pole Telescope, noticed something peculiar, faint asymmetries, almost like scars, scattered across the CMB map. Most scientists chalked these up to noise or calibration errors. But Dar, ever the skeptic, wondered, what if these scars are not errors, but fingerprints? What if, as light from the early universe traveled, for billions of years, it passed through the warped space-time around ancient time-stretched stars like Eco? To test this, Dar and her collaborators developed sophisticated simulations, sending virtual beams of light on a journey from the primordial fireball through a universe littered with collapsed stars and frozen collapses. In their models, each passage near a gravity well stretched, redshifted, or even delayed the CMB photons. The result was subtle but undeniable. Patches of the sky where the CMB arrived slightly later, or were shifted in energy just enough to be detectable if you knew how to look. The implications are profound. If Eco 7-like objects existed in the early universe, their gravitational fingerprints might be embedded in the CMB, forever distorting our view of cosmic history. Every map, every theory, every estimate of the universe's age or structure could be off, just a little bent by the ghostly gravity of dying stars. This perspective caught fire. Teams at NASA, ESA, and Japan's JAXA launched a new generation of CMB surveys, targeting the faintest, most suspicious anomalies. Theorists raced to refine their models, adding in the effects of slow collapses and gravity well plateaus. Some even speculated that entire epochs of cosmic history might be hidden from view, lost behind the time shields of ancient stars. Viewers following this scientific race found themselves asking philosophical questions. If our cosmic history is filtered through the distorting lens of gravity wells, do we really know where or when we came from? Is the story of the universe as clean as we thought? Or are we reading an epic that's been redacted, its most dramatic scenes warped by the lingering echo of stars that refuse to die? For Dr. Dar, the search became personal. She recalled a childhood memory, her grandmother telling stories of ancestors lost to time, their faces fading in memory, their names lingering in family legends. Maybe the universe is the same, Dar mused during an interview. It remembers its own ancestors in light, but the record isn't perfect. It's been shaped by all the things it's passed through. We're reading a history written by survivors. As the data poured in, a new movement took shape. Citizen scientists and amateur astronomers around the world began combing through open CMB datasets, searching for patterns, correlations, new anomalies. Online communities compared findings, debated theories, and even organized global light hunts. Virtual events where thousands searched for the fingerprints of ancient gravity wells. The universe, it turns out, is a palimpsest, a manuscript, written, erased, and rewritten countless times. Each layer, each new distortion, tells a different part of the story. Objects like Eco 7 may be rare, but their effects are eternal, subtly bending the arc of cosmic history. So what does it mean for us? If the story of the universe is written in warped light, are we missing the truth? Or are we simply seeing another kind of beauty, the beauty of imperfection, of survival against the odds, of echoes that linger far longer than any single life? Or star, if you could peer back through the fog of time, what voices would you hope to hear? What forgotten moments would you want to reclaim? In every patch of ancient sky, a new question arises. Are we reading the story of creation, or just the shadows left behind by stars that refused to be forgotten? The universe, for all its grandeur, is a place where even the mightiest fires must eventually fade. The end of time is not a sudden extinguishing, but a process of long, slow unraveling written into the very structure of reality. With we glimpse not only the death of a star, but the shape of cosmic endings themselves. Here, the question turns existential. What does it mean for time to end? And could it, perhaps, end not with a bang, but with a freeze? The story begins with heat death, the ultimate fate that physicists believe awaits the cosmos. Stars burn. Their fuel, galaxies grow old, black holes evaporate in a final shimmer of Hawking radiation. At last, only faint, scattered particles remain, drifting in darkness. Time, as we know it, loses meaning when nothing changes, when no events mark the passage from one moment to the next. The universe becomes a cemetery of seconds. But what if, in this distant future, a star like Eco 7 endures, trapped in its gravity well plateau, never quite collapsing, never truly shining? It lingers as the last monument to a universe that once blazed with light. Around Eco 7, time is stretched and strained until it barely flows at all. Clocks, if any could still exist, would take millennia to tick even once. Physicist Dr. Thomas Velasquez, running simulations in a quiet, midnight-lit office, wonders, aloud, if the rest of the universe has gone cold, but Eco 7 still remains paused, time frozen, radiating only the faintest ghosts of energy. Does it become the final observer, the last spark of order in a sea of entropy? We often imagine the end of all things as a dramatic curtain faller, supernovas blast, a black hole's devouring, a final flicker. But the most likely reality is far more chilling. Time doesn't end with a cataclysm, but with a whimper as the last processes slow and finally stop. The freeze of Eco 7 becomes the freeze of everything. And yet, this is not mere nihilism. In the paradox of Eco 7, there is a kind of strange hope. If time can slow and stretch Faye, a region of space can linger while the rest races ahead, then perhaps nothing is ever truly gone. The memory of stars, the record of their pulses and collapses, might persist in slow motion, endlessly looping while the rest of the cosmos sleeps. This cosmic stasis carries a sense of melancholy but also of preservation. A natural time capsule, holding the echoes of life, matter, and energy, waiting for a future that may never come. Eco 7, in its silence, becomes a testament not to destruction, but to the endurance of memory. It's not just physics that feels this weight. Philosophers, artists, and ordinary viewers ask, if you knew the universe would end in a freeze, how would you live today? Would you race to burn brighter, knowing all fire fades? Or would you find beauty in the act of lingering, savoring each moment in the knowledge that every second is a victory against oblivion? Online communities create art inspired by the last star images of an endless twilight, poems to the final heartbeat of time. Digital music stretched to infinite slowness. Some comment, maybe the universe is a painting, not a story, something to be looked at forever, not rushed to its conclusion. And there's one final twist. If time can end, can it begin again? Some cosmologists, inspired by the echoes of stars like Eco 7, suggest that the freeze is not the true ending, but a pause, a prelude to a new cycle, a new Big Bang birthed from the final stillness. Perhaps, somewhere in the silence, new physics will ignite, and the slowest star will become the seed for a universe reborn. For now, Eco 7 endures, its slow collapse echoing through the emptiness. If you could travel there in the far future, you might find a monument in the darker cosmic statue, frozen at the end of time, still holding the secret of what once was. So, what do we do, knowing all this? We look up, we listen, we tell stories, because in a universe where endings are slow, stories become the way we keep time moving, even as the clocks wind down. If you could leave a message for the final star, what would you say? Would you ask it to remember you, or to dream a new beginning from the last breath of the old? When time ends, perhaps memory is all that remains. From the edge of the universe to the depths of Eco 7, one truth persists. Reality is not absolute. It is filtered through the act of observation, shaped by the position, speed, and gravity of the observer. In the world of collapsing stars and stretched time, this principle is no longer a quirk of quantum physics. It is a cosmic drama, unfolding on a stage larger than any mind can hold. Welcome to the observer's paradox. From our vantage point, light years away and insulated from Eco 7's crushing gravity, we watch its collapse as if it takes eons. Decades and centuries pass on Earth, while, according to Einstein's equations, for Eco 7 itself, the drama is already over. The star has imploded. Its final act is written, unseen, behind the veil of stretched time. Both stories are true and, yet, they contradict each other. Astrophysicist Dr. Leela Monroe describes it this way: for the star, collapse is swift a heartbeat, a flash. For us, it's an endless moment, never quite completed. There is no single story, only perspectives braided together by the rules of relativity. She draws a timeline on her chalkboard, two lines diverging at the point of collapse, each equally real. This is not just theory. Every day, satellites orbiting Earth experience time differently from clocks on the ground. Muon's particles born high in our atmosphere live longer as they speed toward the Earth, time stretched by their rapid motion. The universe does not play favorites. Every vantage point is legitimate, every timeline unique. Yet with each, the paradox scales up to cosmic proportions. For outside observers, the star's surface seems to slow, asymptotically freezing as it nears the critical threshold. Its light grows redder, fainter, its pulse drawn out. From within, everything feels normal. In a sense, the star has moved on while its image is left behind, ghost imprisoned in stretched seconds. What does this say about reality itself? Is the universe made of facts or of perceptions? Does an event happen if no one sees it? Completion? Are we living in one version of time or in a tapestry of overlapping truths, some of which we will never witness? This paradox haunts scientists and philosophers alike. The universe, it seems, resists our need for neat endings. The truth is always relative, a function of where you are, how you move, and what you choose to see. For viewers, the implications are deeply personal. Our lives, too, are filtered through perspective, memories colored by emotion, moments stretched or compressed by attention. We each carry our own version of time, our own story of the universe. Eco 7, frozen in its cosmic limbo, becomes a mirror reflecting not just the physics of time, but the poetry of perception. This insight inspires a wave of artistic and scientific collaboration. Musicians compose pieces that change tempo depending on the listener's heartbeat. Digital artists create paintings that morph based on the viewer's location. An international exhibit, Relativity, invites visitors to walk through rooms where clocks tick at different rates, mimicking the experience of time near a massive star. Students watching from around the world are asked, if you could see the universe from any vantage, which would you choose? Would you stay on the outside, watching events stretch into eternity, or dive in, living a brief, blazing instant? The observer's paradox also has practical consequences. As our technology advances, space travel and time dilation will affect everything from communication to navigation to the search for extraterrestrial intelligence. Messages sent from deep gravity wells may arrive decades or centuries out of sync. Colonists on distant worlds may experience years while those on Earth age only months. As the world wrestles with these possibilities, one thing is clear: the universe does not offer a single narrative. It offers infinite stories, each shaped by the observer, each a facet of a deeper, stranger reality. Eco 7 will forever be both dead and dying, gone and present. A puzzle visible only from the angle you choose to look. And in that realization, we are reminded that the greatest mysteries of the cosmos and of ourselves are never solved, only witnessed from different shores of time. For so long, we have gazed outward to dying stars, swirling galaxies, the cosmic horizon, in search of answers to the mysteries of time and existence. But what if the true echo of Eco 7 is not only in the heavens, but deep within us? What if the story of a collapsing star is, in some way, the story of every living thing? The forces that tear apart suns are the same forces that shape our lives, our memories, and our inevitable endings. Consider the ingredients of your own body: carbon, calcium, iron, oxygen. Every atom heavier than hydrogen was born in the heart. of a star, some in explosions, some in slow, silent collapses like Eco 7. We are, as Carl Sagan once said, made of star stuff. But there's more to it than poetic origin. The physics of collapse, of entropy and time, unfolds inside us with every heartbeat, every thought, every moment we age. Entropy, the tendency of systems to move from order to disorder, is the driving force behind the arrow of time. It is why memories fade, why bodies weaken, why no 2 days are ever the same. Just as Eco 7 collapses towards stillness, each cell in our bodies resists the pull of disorder for a while, fighting to repair, rebuild, and remember. Yet the collapse is never entirely held at bay. Life, like a star, is a balance between energy and gravity, growth and decay, creation and dissolution. Dr. Annika Dar reflects on this cosmic kinship late one night, staring at electron microscope images of aging neurons. We're all collapsing stars, she muses. Each of us is a tiny echo of that cosmic struggle, a universe of atoms waging their own battles against the slow pull of entropy. But perhaps the most striking parallel is the idea of time dilation, not in seconds and minutes, but in the way we experience our lives. For a child, a summer lasts forever. For the elderly, years flicker past like the final pulses of a fading star. Time is elastic, shaped by memory, emotion, attention. Sometimes it races, sometimes it slows. Each of us is both observer and observed, living through our own unique flow of time, stretching some moments, compressing others, unable to ever return. If Eco 7 is a cosmic freeze frame, a moment stretched toward eternity, are there moments in our lives we wish we could stretch the same way? A last embrace, a first step, a word unspoken, a laugh shared at midnight, each a heartbeat we wish would linger forever. If we could, would we freeze them, keep them safe from entropy's slow unraveling? Or does their fleeting nature give them meaning? Artists, poets, and scientists alike have always grappled with these questions. Around the world, people write songs and stories about lost time, about youth fading and wisdom growing, about the bittersweet ache of memory. The story of Eco 7 resonates, not only as a puzzle of physics, but as a parable. What collapses is not always lost. What lingers, even at the edge of darkness, is worth cherishing. We live in a fractal universe, where patterns repeat on every scale: the collapse of stars, the fading of galaxies, the aging of a single cell. Each is a verse in the song of entropy, a line in the poem of time. Perhaps, as we strive to understand Eco 7, we also come closer to understanding ourselves online. A new movement takes root, #StellaWithin. People share their moments, goodbyes and beginnings, triumphs and losses, tying their lives to the cosmic story unfolding light years away. We're all collapsing stars, writes one user, trying to shine as long as we can. So, the next time you look up at the night sky, remember, the drama of Eco 7 is not only out there, but within you. Your existence is a miracle of time, a brief rebellion against the slow, patient pull of entropy. Each breath, each heartbeat is a victory over cosmic collapse, and if, in the end, we must all yield to gravity and time, let us do so with wonder, with memory, with a light that endures, even as it fades. At the limits of knowledge, where mathematics blurs and language falters, we find ourselves standing before a final question. What lies beyond time itself? Eco 7, in its strange suspended collapse, has shown us that time can slow, bend, and nearly stop, but can it end? Or is there something deeper, something more fundamental, beneath the ticking of every clock and the pulse of every star? In the aftermath of Eco 7's discovery, philosophers and cosmologists gather at conferences, in late-night video calls, and in solitary reflection. Grappling with this question, Dr. Leela Monroe, whose work helped decode the time signals from Eco 7, sums up the riddle. If time is just a property of space, and space can be bent or broken, then maybe time is not the stage, but the play, something that emerges rather than something that rules. This is the realm of emergent time, the idea that time is not absolute, but a product of deeper laws. In quantum gravity, some theories propose that time is an illusion born of entanglement and change, that underneath there is only a network of relationships, a web of information evolving according to patterns we can barely glimpse. In these models, what we call the flow of time is simply the appearance of change in an underlying, timeless reality. What would this mean for Eco 7? Perhaps its slow collapse is not just a distortion of seconds, but a glimpse through the cracks in reality itself, a place where time's mask is lifted, and we catch a fleeting glimpse of the machinery behind the curtain. What we experience as freezing or pausing might be the breakdown of time as an emergent property, the fading of the story as the stage itself dissolves. Some scientists turn to the strange results from the edges of black holes, where information seems to survive, encoded in subtle patterns at the boundary. If Eco 7 is a paused collapse, maybe it is a natural laboratory for such boundaries, a place where reality hints at something beyond the familiar. Perhaps the slow, eternal moment at the edge of Eco 7 is a doorway, not to death, but to a deeper kind of existence. Artists, mystics, and thinkers respond in their own way. New music is written to evoke the sensation of timelessness. Visual art attempts to portray the shimmer of something just out of reach. People meditate, seeking moments outside of ordinary time, inspired by the cosmic freeze frame of a star that will not die. Dr. Mina Solberg, a quantum philosopher, proposes an analogy. Imagine a book where the story seems to end, but the pages continue, blank, but filled with the potential for anything. Perhaps, beyond time, we are all unwritten pages waiting for the next story to begin. Online, conversations blossom. What would it mean to live without time? Would memory exist? Would self? Would anything? Viewers are invited to imagine not just the end of clocks, but the emergence of something stranger, a reality where change is possible without duration, where cause and effect are replaced by new rules we cannot yet fathom. As Eco 7's data continues to flow, humanity stands at the brink of a new understanding. We have seen the universe slow, pause, and nearly freeze. We have watched light stretched into infinity, heard messages frozen in dying radio waves, felt the chill of entropy and the ache of memory. We have learned that time is not merely a measure of motion, but a tapestry woven from matter, energy, gravity, and mind. So what lies beyond? Perhaps the question is not what, but how. How do we meet the unknown, with fear or with awe? With a desperate clutch at what was, or with an open hand? For what may yet be, Eco 7 does not offer easy answers. It offers a challenge. To peer into the dark, to listen for the last echo, to wonder what stories are waiting beyond the edge of time. And as you look up at the night sky, at the scattered light of stars, both living and dying, remember, the story is not over. Not for the universe, not for us. Time may slow, may stretch, may vanish, but the search for meaning and the courage to imagine what comes next is truly timeless. If a single dying star can bend time, what else could be out there? What secrets are hidden in frozen light, stretched seconds, and gravitational ghosts? Share your theory below. Maybe you're the one who will uncover the truth behind time itself.